Hello everyone, welcome to this presentation. Today I'm going to talk about hardware data acquisition, and in this lecture I want to talk about one type of data acquisition, USB-6009. This is a type of multifunction I/O device, and in the next step I will explain for you hardware wiring, and finally we will speak about 5 examples for hardware wiring from sensor to data acquisition. So, USB 6009, this is a type of data acquisition. We have 8 analog input and 2 analog output and 20 digital input and output. This type of data acquisition the sampling rate is about 48 kilosample per second, and this is a type of data acquisition with 8 analog input, and resolution is about 14 bit. This is a type of low-cost data acquisition and multifunction. What does it mean, multifunction? It means that we have 4 types of input and output. We can measure or send a command from this type of data acquisition. As you can see, we have 8 analog input and 2 analog output and 12 digital input output. And there is another specification for this type of data acquisition. We have a counter with 32-bit resolution. In this data acquisition, module specification is that we have an analog input. If you want to use this type of analog input as a differential format, the resolution is 14-bit. If you want to use this type of USB as a single-ended, you can there is a 13-bit as a resolution. So the maximum sampling rate for this type of module is about 48 kilosample per second. As you can see in this picture, there is one USB port. You can connect data acquisition to the PC or laptop or any system you want to use. So this type of data acquisition is a portable and USB based. As you can see in this picture, the manufacturer is National Instrument, and we have one USB connection. You can use it to connect to the USB to the PC or laptop or any devices you want to have. this slide, I want to explain device pinout. In the left-hand side table, we have terminal and analog input, and in the right-hand side, we have a picture for data acquisition USB-6009. In the left-hand side table, you can see AI0 or analog input 0. The terminal number is 1 and 2. Terminal number 1 is connected to ground, and terminal number 2 is connected to analog signal. For terminal number 3 and 4, you can use AI4 or analog input 4. Terminal number 3 is connected to the signal, and terminal number 4 is connected to analog ground or ground. In the analog number 8 or AI7 is connected to terminal number 12 and terminal number 13. Terminal number 12 is connected to AI7 or analog input signal, and terminal number 13 is connected to ground. In this table, you can see two analog output, and we can use in the data acquisition card. Analog output 0 is terminal number 14, and analog output 1 is connected to terminal number 15, and terminal number 16 is connected to ground. So as a result, I can say that we have two analog output 0 and AO0 and AO1 is connected to terminal 14 and terminal 15, and we have 8 analog input AI0, AI1, AI2, AI3, AI4, AI5, AI6, and AI7. It started from terminal 1 until terminal 13. Another side for data acquisition USB-6009, we have terminal 17 until terminal 32. In terminal 17 until terminal 32 is covered by digital input and output. And you can configure that sometime as a digital input and sometime as a digital output, or some pinout as a digital input and some pinout as a digital output. As you can see here, port number 0 is included from 0 until 7, terminal 17 and to terminal 24, and we have a four digital input for port 1 from port 10 until port 17, and terminal number 25 until terminal number 28. As you can see here, we have two power supply output, and the level of the voltage is 5 volt and 2.5 volt. And so one side as a result, I can say that one side from terminal number 17 until terminal number 72 is covered by digital input and output. Another side of the data acquisition from terminal number 1 until terminal number 16 is covered by analog signal, such as the analog input and analog output. Also, both sides we have two level of power supply, 5 volt and 2.5 volt. This is a configuration for USB data acquisition. Also, in this picture, you can see we have you can see in the number 4 we have one USB port or USB connection. You can connect the data acquisition to PC by a USB cable. If you want to connect two type of analog signal, one type is single-ended voltage signal and one type is differential voltage signal to data acquisition USB-6009, we have two type of configuration. One type, if you want to connect single-ended voltage signal to data acquisition, connect the positive lead of the signal to the AI positive terminal and the negative lead to the ground terminal. So And this is a configuration if you want to connect single-ended voltage signal to data acquisition, positive signal to positive lead area of data acquisition, and negative signal to ground terminal for data acquisition. So if you want to connect differential signal voltage, connect the positive lead of the signal to AI plus terminal and negative lead to the AI minus terminal. So positive signal to AI plus lead, and negative signal to AI minus lead of data acquisition signal. So this is a two type of configuration: single-ended differential voltage signal. In the single-ended, positive signal to AI lead and negative signal to ground. In the differential format, positive signal to AI plus terminal for data acquisition and minus signal, sensor signal to connect will be connected to AI minus terminal for data acquisition card. How you can connect analog output to a load? To connect load to the USB 6009 or 8, connect the positive lead of the load to the analog output terminal and connect the ground of the load to a ground terminal. If you want to send the command to a proportional actuator, you need to connect analog output of data acquisition to analog actuator. So you can connect AO terminal for data acquisition to positive lead of load and ground terminal of data acquisition to a minus terminal of load. This is a configuration we want to connect analog output to the proportional actuator or analog actuator. So it's very easy to use this type of format for our circuit. So analog AO positive signal to to positive signal of load and ground terminal to minus terminal of load. That's it. How we can connect digital input and output to data acquisition system? USB data acquisition system has 12 digital line. Port 0 is include from 0 to 7, and port number 1 is include from 0 to 3. In this figure, as you can see, P0.0 configured as an open collector digital output driving LED, and line P0.4 configured as a digital input receiving a TTL signal from a gate inverter. So as you can see, P0.0 is configured as a digital output and P0.4 is configured as a digital input. Also, as you can see here, P0.7 is configured as a digital input, and we can use this type of input to sense the switch or micro switch or digital switch. So this is a configuration as we want to measure digital line or send the command to the digital output. So we have two type of signal in the digital line. One type is digital input, one type is digital output, and you can configure in the software, for example, P0.0 as a digital output and P0.7 as a digital input, or P0.4 as a digital input. It's very simple to connect digital input and digital output to data acquisition card, and we can measure by data acquisition card digital signals. Now I want to explain about 5 examples for hardware wiring. In this example, I want to explain for you how we can connect some sensor to data acquisition, such as the analog input sensor, analog sensor and digital sensor. How we can connect analog sensor and digital sensor to data acquisition card. In the first example, we want to connect a potentiometer to a data acquisition, to input of data acquisition, such as the AI0 or analog input 0. As we talked before, how we can wire a single-ended analog input to data acquisition. In this example is the same. A potentiometer pin, there are three pin in the potentiometer. One of them is ground, and a supply is supplied by 5 volt and a real or actual voltage or real signal from the middle pin of the potentiometer. So as you can see in the left hand side of the picture, potentiometer, one pin of potentiometer is connected to 5 volt and one pin is connected to ground, and middle point is a signal, or S is connected to AI0 or terminal 2 for data acquisition card, and analog and ground of the power supply is connected to ground of data acquisition terminal number 1. It is very simple to connect or to read analog signal from the physical environment to data acquisition, and how we can read analog signal from the potentiometer by the data acquisition card USB-6009. It's very simple to understand and very simple to wiring. We have two wire, black wire and light blue wire. Black wire is a ground and light blue wire is AI0 or signal from potentiometer is connected to terminal 2 to read this type of signal. Another example to measure the analog input. In this picture you can see I want to connect a gas sensor such as MQ2 to data acquisition card. The following picture shows how to connect data acquisition with the MQ2 sensor as a gas sensor. According to the picture, in the MQ2 module, we have 2 pinots. One pinot is for a 5 volt as a red line, and one pinot as a black one is a ground. We connect the power supply to the module, and the output of this module is a light blue line, such as the signal line. We connect the signal line to terminal number 5, AI1 or AI plus, and because this type of sensor is single-ended sensor, we connect the black line or ground to the terminal number 7. By this approach, this configuration, we can connect a gas sensor module to data acquisition and to measure the level of the gas in the home, in the residential area, in the industrial environment. So it's very simple to connect MQ2 module to data acquisition and measure the level of the signal, measure of the level of the gas in area by data acquisition card. So light blue line is a signal or analog signal we can measure by terminal 5, and we can connect it to analog input number 1. So how we can connect a push button switch to data acquisition card? As we learned before, terminal 17 to terminal 28, we have 12 digital input, and in this slide we want to learn about how we can connect a push button switch to digital input number 2. One side of switch is connected to ground, and we connect terminal number 3 from data acquisition as a ground to one terminal of the switch, and signal terminal or terminal number 19 from the data acquisition card or P0.2 pinote we connected to the digital input signal to one side of the switch button. And this is one approach to connect a push button switch to digital input number 2, or sometimes we can use it another pinote such as a pin number port 0.3. So one side is connected to the ground, and one side or signal of the switch we can connect to every pinote or every terminal for digital input we want to have a connection. Example 4, I want to explain about wiring diagram PIR motion sensor. PIR, it means that passive infrared sensor, and this is a type of digital sensor we want to connect to data acquisition digital input number 0. We need to have two power supply for that, for the PIR sensor or PIR module. The red one is positive, 5 volt is connected to the module, and ground from data acquisition is connected to the PIR sensor or PIR module. Output of the sensor is a light blue line, or we call it signal. Signal is connected to port 0 or pin 0.0 as a digital input. So by this configuration we can learn digital signal from the sensor, or sometimes is one digital 0 and sometimes will be digital 1. It depends on the case of or state of the PIR sensor. So signal can measure by data acquisition from digital input number 0. As you can see in this picture, before we connected to a PIR sensor to digital input digital input 0 from data acquisition card. As you can see in this picture, black one is ground, is connected to the module. Red line is positive 5 volt, is connected to the module, and yellow line is a signal line, is connected from sensor to data acquisition digital input 0. And as you can see in this picture, there is one USB connection and is connected to the PC by a USB cable. So by this approach we can read a 0 level or 1 level digital signal from the sensor by data acquisition national instrument USB-6009. In example 5, we want to learn about wiring diagram for steam water detection. It's the same with previous sensor or digital sensor. We have two wire for power supply. The red one, we connected 5 volt to the module, and the black one, we connect the ground to the ground of module. And we have a light blue line is a signal line we connect from the sensor or a steam water sensor is connected to terminal number 18 or digital input P0.1. It's very simple to have a diagram, wiring diagram. We have two signal for power supply and one signal is connected from sensor to data acquisition card. We call it signal or data line. In this picture you can see wiring diagram for steam water detection. It is done before between the data acquisition card and steam water sensor. Yellow one is signal line, and red one and black one is a power supply line, and this sensor is connected to data acquisition card, and the yellow one is a signal line we have in this picture. In last example, example number 6, I want to connect LED lighting to data acquisition card. Terminal number 20 is a digital output, or pin number 20 or P0.3 is a digital output. We want to connect to LED module, and we have two wire. Red one is a power supply 5 volt, and black one is a ground, is connected to power module, and signal is command signal is sent from data acquisition to LED module, and if the command is 1, LED will be turn on, and if the digital output is 0, LED will be turned off. So we have a connection between P0.3 to signal of the LED module. You can see here the wiring diagram for LED lighting, and LED is connected to the USB data acquisition card. LED act as a digital output and act as a digital output. So in this slide you can see all part wiring such as the MQ2 sensor, LED module, PIR sensor, and steam water sensor. You can see sometime LED is on and off, and we can measure the level of the gas by data acquisition. We can measure the PIR action. We can measure the steam water action by data acquisition card. In this slide you can see all part wiring diagram. So in the last slide I want to have a comparison between the price. It depends on which company and which website you are ordering. It's about 97 pound until 130 pound. It depends on which company and which website are you ordering. Is about 100 you can have one data acquisition. You can use it in the industrial environment or in the research area and work, and you can use it in which area do you want to use. Thank you for your attention. I hope to see you again in our next meeting. Thank you so much.